is we're going to go over 3 of these models. The rest of the models are very similar with one another. These 2 models offers the blood vessels. So first I would like to go over maybe the structures, and then at one point in time I'll go over the blood vessels. So let's go ahead and take a look at the structure. This the thin layer on the outside that is darker is known as renal capsule. Renal capsule. All right? Now, the renal capsule prevents from the infection, and then you have this structure right over here, which is, you can see it all the way in here. And this model is a little bit better because it's all uniform in color, so all this kind of like a superficial structure, these are called cortex. Cortex. And this part right over here is called medulla. The medulla is the pinkish color in here. And again, it's called sometimes medullary pyramid because it looks like pyramid. But when you slice it in a mid-sagittal cut, then you can see as a triangular shape. At the tip of the pyramid lies the papilla of the medulla or medullary papilla right over here. So as the urine starts forming and going through these nephrons, it empties in here. The next structure happened to be the minor calyx. These are these spaces in here. Minor calyx has a small diameter. This number 11 is minor calyx. This one right here, minor calyx. This one right here, another minor calyx. So urine forms, goes into this opening, minor calyx, then goes into the bigger diameter. In other words, 2 of the minor calyx, they join in the major calyx. See this one? Minor calyx, now major calyx. Major calyx has bigger diameter. Many of the major calyx, they become a funnel-shaped structure known as a renal pelvis. This is a renal pelvis. Look how funnel-shaped it is. A renal pelvis, then it goes out of the kidneys into the ureter. All right? So same thing in here. This is the renal pelvis, and here is the ureter. Okay? So this structure, one of these structures right here have been expanded, and you're going to see only one of the pyramids in here. So again, you will see the nephrons in the white, you see the papilla, and this space is got to be this one right here, which is minor calyx. All right, next up, we wanted to go over the blood vessels. These 2 models offer pretty good blood vessels. So we started from the renal arteries. Once it's split, becomes segmental artery. So these are segmental artery, these are segmental artery. Renal artery, segmental artery. Then it's split into the lobar artery. Then it's split into interlobal artery. So you could see lobar artery, and then it splits into interlobal artery. Then it goes and becomes kind of like in the junction where the medulla and the cortex is. This, they go into the same. See right over here is the cortex. All this area is cortex. This is the medulla. You see these are all arcuate arteries and arcuate vein. All right, off of the arcuate arteries, it goes upwards. This one that goes upwards, kind of like a perpendicular to that, is called interlobular artery. Interlobular artery. And then interlobular artery goes into the glomerulus, but what is leading to the glomerulus right here is the afferent arteriole. When it comes out, that is called efferent arteriole. So we go ahead and take a look at this small section. In enlarging it, you see afferent arteriole, you see efferent arteriole. The way that you could tell, you have to look at the diameter. Afferent arteriole always have bigger diameter than efferent arteriole. Furthermore, afferent arteriole leads to the glomerulus. These are the glomerulus. Glomerulus means ball of capillary, all this structure. Now, these are fenestrated capillaries, so you could see down here, you get close up, you might be able to see tiny little pores in there, tiny little holes. Those are called fenestrated capillaries. All right, embedded on top of these, you can see the podocytes. These are podocytes. The podocytes, kind of like my fingers, as I told you earlier, they're not covering 100% next to one another. You see filtration slits right here. These lines representing filtration slits. So, what comes inside of the blood, all the small things like water, ion, things like that, they're coming out into this area right here. That is the Bowman capsule. Bowman capsule. They're coming out of the fenestrated capillaries, out of these filtration slit. Now they are inside of the Bowman capsule. Together they're known as a renal corpuscle. Bowman capsule plus the glomerulus, together they're known as renal corpuscle. Glomerulus plus Bowman capsule, renal corpuscle. Now, the very first part where most of the reabsorption takes place, this is a PCT, proximal convoluted tubule. Proximal convoluted tubule can be observed in here too. See, it's coming out of this. This is a proximal convoluted tubule right here. It's not a straight, it's convoluted. Then you go to the loop of Henle. So the one that is going down is descending. The one that is going up, ascending. Again, how do you know which is which? Start from the Bowman capsule. The one that is connected to PCT is the descending. And then continue is going to go ascending and connects to the distal convoluted tubule. This is called distal convoluted tubule. Distal convoluted tubule reach the collecting duct. These are the collecting duct. And again, the end of the collecting duct goes into the tip of the papilla. We mentioned this. All right? So, these are the part of the nephron. So one more time, we got the Bowman capsule, PCT, proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, and collecting duct. But let's go back in the descending distal convoluted tubule. Look how close it is to the Bowman capsule, but they're not really connected. They're very close to one another. So if you can picture this one as a Bowman capsule, this one as a proximal convoluted tubule, and imagine that is a tube going down inside of this table, and then it's coming back up here. And this is very close to this region, you guys. And therefore, this gotta be the distal convoluted tubule. You have to think three-dimensionally. All right. Now, going back over here, this part that is going in, we said is afferent, is bigger diameter. This part that is going out is efferent. Then what happens? Then it goes and surrounds the collecting duct and all the other region and so on. These are called peritubular capillaries. So, from here, afferent arteriole, efferent arteriole, these are the peritubular capillary that is being cut. In reality, they're going to go around the nephrons. All right? Next up, we need to talk about some parts that we missed out. So let's go back. So we went over the nephron, different parts and different blood vessels. Let's go back over here. Between the renal pyramids lies renal column. So this structure right here is called renal column. This is another renal column. I'm not talking about the blood. I'm just talking about the structure right here. This is called renal column. I think we skipped that. We didn't cover it. This is the adrenal gland. This is adrenal gland. Now, there are two types of nephron. One is shorter, and we have a lot more numerous. About 85% of the nephron are this kind. These are called the cortical nephron. This is a more deeper loop of Henle, goes more deeper down to the medulla. This is called juxtamedullary nephron. Juxta means next to, medullary, medulla is deeper, nephron. Juxta, next to, medullary, medulla. So this is deeper. Blood vessels that are associated with it is called vasa recta. You don't need to worry about that right now. Okay? So, those are this model. And this model is very much similar. Again, this is a part of a nephron. Are you okay? I'm sorry. Okay, so you can again see it, the same thing. Here's the interlobular, this is a glomerulus, this is Bowman capsule. It's very small, but if you get a chance to get close up, you can see it. There's a PCT, loop of Henle, DCT, and then collecting duct, which gets into the minor calyx again. Over here, you can see the renal fascia and the adipose tissues that we mentioned. Let me go over here.